Hi, I'm
Hi,
Leonard
I'm Leonard
Facchinetti,
Facchinetti,
and
and
let's
let's
write some
write some
code
code
and build
and
some
build some
hardware
hardware
together,
together,
shall we?
shall we?
So what we
So
have on
what
the
we have
menu
on the
today
menu
is to
today is to
continue this
continue this
project that
project
is
that
a
is a
MIDI
MIDI
controller
controller
that is
that
meant to
is
be
meant to be
operated with
operated with
my
my
feet,
feet,
and
and
it is
it
going
is
to
going to
include an
include an
expression
expression
pedal and
pedal
some
and some
buttons,
buttons,
and
and
it's going
it's
to be
going to be
controlled with
controlled
an
with an
Arduino,
Arduino,
and we are
and we are
building this
building
from
this from
scratch in
scratch
this
in this
stream.
stream.
So
So
let's
let's
jump
jump
in
in
and
and
continue
continue
from where
from
we
where we
left
left
off
off
last week.
last week.
So
So
here in
here
front
in
of me,
front
you
of
can
me,
see
you
that
can
I
see
got
that I
some
got
new
some new
parts.
parts.
I
I
specifically got
specifically
a
got a
proto board.
protoboard.
And
And
usually this is the
the
kind of thing that you would use to
use to
prototype.
prototype.
It's a proto board or a breadboard. So it's usually the kind of thing you would use to prototype. But I think that I'm going to use this for the final project as well. I can just take out this thing here and I can just glue it to the enclosure, and that is probably good enough. I'm not thinking that I'm going to put too much pressure on this project. It's not going to be taken on tour or anything. It's just going to sit here on my studio. So it's mostly something that I'm not going to throw around. And then soldering would probably be a better idea if I had to throw this around. But since it is just something that is going to sit here, I think that a proto board prevents me from having to solder a lot. And I don't like doing that. I'm not good at that. Also, it gives me more flexibility. So if I decide that I need to take this project apart and do something else with the parts, very easy to do with a proto board, kind of hard to do if I solder everything. So yeah, that's something that I got this week, and I pushed the Arduino micro into the breadboard. It wasn't exactly easy. I had to exert more pressure than I was expecting to get this to work and to put this on the board, and I had to like press from all sides, and I had to find something to put on here to be able to press. And I was afraid that I was gonna like break the board doing that, but I didn't. So that's great. And then another thing that I got was this super cool part. I didn't even know this existed, but it exists. So let me show you what it is, and then I can show you how I mounted it. It looks like this. It is the female jack for the cable that comes with the expression pedal. So I will have some buttons on the MIDI controller, but I also want to have an expression pedal for things like volume and maybe a wah-wah. Could be fun. So expression pedal comes with this kind of jack, and this is the female part, so it just connects right in. But the cool thing is that this can be plugged into the breadboard. Well, not exactly, really. That was the promise on the store, and the lady that sold me the part said that it would just fit into the breadboard. It didn't. So these four outer pins do connect to the breadboard, but these two middle pins do not. So I had to hack something together. I just, on this one that is on the breadboard, as you can see, and you can see that it's like poking at the bottom, so this is definitely a hack. I don't think it was meant to be used this way. In any case, I just broke these middle connectors right about here where they thin out, and then I said that I was gonna try to avoid soldering, but I did have to solder this one part. I think that I'm gonna get away with doing the whole project with a single place where I had to solder something. So this hack is just a little jumper cable that I soldered into the middle connector, and then I pushed the other part of it into the breadboard. And I'm not sure you can see this, but yeah, I broke the middle pin. It's not connected anywhere. See? So kind of a hack. Does work. I tested everything and it works. So let's go over some things that we left off last time. So now I have this button here that we prepared last time. So last time we were together last week, I said that this is the kind of button that does not remember its stage. And that's actually a good thing. I want the state to be remembered in the board. And if I really think it warrants that, then I will do some LEDs to indicate the state, but the button itself does not remember state. It's not one of those stomp boxes buttons where you press the button and it stays down, and then you press it again, it comes back up. No, this is just single, you press it, and then you release it, and that's the end of that. And it only has two connectors, two pins. And as far as I know, this is symmetric, really. So it is like an interrupter. It's just going to let electricity go through or not. When the button is up, electricity does not go through. When you push the button, electricity goes through. And then when you stop, it stops sending electricity around. And I kind of wanted to play with the button last time. We wrote the code for this, but then I wasn't able to actually plug everything because I didn't have the breadboard. But now I do. So let's do the connections of these pins. I'm going to zoom in so that you all can see what I am doing on the Arduino. And the Arduino Micro, well, as the name suggests, is super small. And then the indications here are very small. The little labels next to the pins are very small. So I will have to like bend over the thing to be able to see it. But let's talk about the breadboard a little, and let's even talk about the multimeter, because I learned how to use this thing a little bit better. Not an expert, but I do know one thing or two about how to use this, and it's going to be helpful in debugging when things go wrong. It's also helpful just to learn how things work. Like to investigate, like the pedal has some weird settings, like this knob here on the side that I didn't know what it was for, and now I do. And it also has this button here, this switch from M audio to other. And what does that mean? Now I know because of the multimeter, and I learned how to use it to be able to answer these questions. And Bo is here, and he says, "Hey, how is it going? Hey, Bo, there's a big delay on your voice. That's too bad. I wonder if I should try to fix it now. I don't think I do. Yeah, I think I'll just have to deal with the delay. Is it understandable? Thanks for letting me know, but to fix this right now, I think would be like annoying because I would have to record something, clap, and then sync everything. But yeah, if you think it's too distracting, let me know. But if you think it's sort of okay, then I think I'm just going to continue. In fact, my head being here doesn't help much. It's mostly what I am doing on the board. Right, so let's take here the multimeter and understand what the most basic setting does. It's this setting right here. It looks like a beep. And it's called a continuity test. So if energy can go through, it beeps. That's what it does. And naturally, when I just I push the two connectors together, then energy can't go through. But it can also be anywhere else, like here in the proto board, in case you are new to this kind of thing. In the breadboard, this line is fully connected. So if I put some pin here and I put another pin there, continuity. And similarly, these rows are connected. So if I put one connector here and another there, yeah, I know that I'm sort of covering this with my hand, but if I try to bend it sideways, it wasn't connecting. And these rows are not connected to these ones at the bottom. So there is this division here in the middle that prevents energy from going from one side to the other. And then similarly here, these two lines are fully connected. So from left all the way to the right, exactly the same as this one. And this is something that you can actually test using the multimeter and the continuity test. Great. That was also what I used to learn what these pins on this thing here would do. Let me show you what I mean. So if you just take it like this and you try to do some continuity tests, you're going to realize that the pin on the left is connected to the pin on the right, but not to the other ones. Right? And then I thought, well, so this thing is symmetric. It doesn't matter which side I connect to what. That's not the case, actually. Because when I push this in, notice what happens here on the side. These parts go up. And this disconnects this plate from this other one. So when the cable is connected, if I try to do the same test I did before, it no longer passes. There is no continuity. This piece is not symmetric. The connectors on this side are connected to the wire or to the jack, but the connectors on this side are not. Another thing that you can learn and figure out using the continuity test. So with that out of the way, let's complete the circuit that we started last week, and we kind of used the jumper wire to see if it was working. And the purpose of this circuit is just to test that a button can send a MIDI message. And eventually, what we want to do is to have this button mounted somewhere where I can press it with my foot. So to realize this circuit, we already have the code. But to realize the circuit, I bumped into the camera. To realize the circuit, I have to connect the button instead of jumper wires into the Arduino. And one side, let me see if I can zoom in even further. No, that's the best we got. So as I said, this thing is symmetric. And let's actually prove that what I mentioned before is the case. So I am going to connect both of these wires to the same row. That means that just like that. Well, actually, let me connect them to different rows. Right? They're connected to different rows. So now using the continuity test on the multimeter,
put these guys in there.
And then we can prove that the button works like I promised it. When I press continuity. Great. Let's realize the circuit now. On one side, we connect this to the ground. On the other side, we connect this to one of the inputs in the Arduino, a digital input, and we used input 7 in our code. So let's find input number 7. That one. And then we can run this code that we wrote together on our last stream. This code right here, and we should be able to push the button and have it send MIDI messages. Right, okay, so let's do this. First, I'm going to check how you all are doing in the chat. Bo says, I can hear what you're saying, but the delay is about the same volume as your original voice. It's fairly annoying. Oh. Okay. Does that work? Yeah, is there a delay now? Because I thought that when you said delay, I thought that there was just an offset, a timing offset between my voice and my camera, but it seems like you hear me twice. And that's no good. But I do have another microphone here, which is the second camera microphone, and now I turned it off. Maybe that helps? Does that help? I don't think that I had that second microphone enabled. Oh, okay. I didn't know that that was even going through. Yeah. Thanks for helping me figure this out. Awesome. Much better. Yeah, there was a doubling. Okay, that's weird. All right. So let me show you. Yeah, let's put this to action. So I am going to go into here, and now I am going to do something that may break the stream again, which is to connect the board. Last time when I was streaming using the Arduino, every time I connected the board, my audio interface would die. Or not even die, really. It would keep running, but it would stop sending audio, and that is super weird. So I'm going to connect this now, and we'll see if I will have to reboot my audio interface. Oh, I think the cable actually goes like this. Okay, and now we are back. I have no idea why plugging in the Arduino stops the audio interface from working. Isn't that the weirdest thing? It is to me. I have no idea why. It just happens, and we'll have to live with that. And I will try to minimize the number of times I actually connect the board, because if I upload a program, that's fine. It's just when connecting the board that makes the audio interface unhappy. Go figure. Right, so everything is connected. The Arduino is plugged in. Let's switch to this view and upload our program for compiling the sketch. And there is a warning here. I think I know what the warning is about, and I know how to fix it. We talked about this last time, and I know what the fix is, I think. So this is done uploading to the Arduino. Let's bring in Reaper, and we will stop any audio from going out. Then put a MIDI logger in the track and enable the track for recording MIDI. Just make sure enabled and it is present. Great. So now I don't have a both this little camera and my screen at the same time. So how about I set this up real quick? Shouldn't be too hard. Just add a second camera and make it smaller. And how about I put it in the corner? Cool. So now we can press the button and hope for the best. Oh, look at that. It worked. Great. But pay attention to sometimes, yeah, like right now, it's sending way more notes than it should. It should only send one note when I press, one note when I release, but it is sending sometimes several of these notes. This is the issue of debouncing that we talked about last time. We don't have any prevention for the state where the button is being, it's in the middle. It's like pressed and not pressed several times in a row, and we need to take that in account and fix that with code. Great. So how about we, yeah, I'll just have a buffer here with a to-do kind of situation. So debouncing is something that we have to take care of. Next, let's put the the foot controller, the expression pedal, to work. I think I'm going to start with the circuit for this. So let me switch back to this, and let's talk about expression pedal, what it actually is inside. Because using the multimeter, I was able to figure it out, I think. Let me move this whole circuit out of the way real quick. I'm going to show you what this expression pedal is doing first, because, well, it's useful for the project, but second, to show you the method I used to understand what this thing does. So, first of all, there is something that I already know about expression pedals, and that's that they are potentiometers. They are essentially just a big thing that you can put your feet on, but it is like a knob in any kind of hardware where you have like one continuous controller. That's what this is under the hood. In fact, some models of expression pedals are just a string that rotates a knob inside. I don't think that's the way that this one works, but that's the principle behind it. And then a potentiometer, oh, the stream is really laggy. That's too bad. Then a potentiometer comes in, well, to connect the potentiometer to the rest of the system. There are 3 connectors. A potentiometer is also something known as a voltage divider. And these 3 connectors, first of all, let's understand what they are in terms of being connected or not. So I can put the negative here, and then in the middle, not connected, and outside, not connected either. So these pins are not connected. You didn't hear any beeps, except for when the thing was like starting. But let's look at another setting. So here in my multimeter, well, it is a multimeter because it can measure different quantities, one of which is resistance. This capital omega is the Greek letter used to represent the unit of measurement for resistance. It's ohms. So this is going to measure resistance. And to measure resistance, we need to do something similar to what we did to test continuity. We need to have this circuit without power. We only turned on the Arduino later. We did all our continuity tests without power. So you leave the circuit without power, and then you connect the connectors as if you were doing a continuity test. You just go through the system. So this outer here, the tip of the TRS connector, has a resistance of 10 kilo ohms. I think that's what it stands for. The little K here is for 10 kilo ohms. And as I move the pedal up and down, well, the stream is not picking that up, is it? Great. Yeah, now it's picking up. So as I move it up and down, the resistance will not change. So, as I said, this is kind of a voltage divider, and all the energy is just going through from one place to the other without with the same resistance at all times. Energy is just going through. But let's look at the divider part of the voltage divider. Let's look at the middle one, the ring connector, this one. And this one, it's kind of hard to connect all these things together and move the pedal at the same time. But you can see that the resistance is lower. It's not 10 kilo ohms. It is more like 1. But as I move the pedal down, the resistance changes. So when the pedal is like this, the resistance for the energy to go from the middle to the sleeve is this part here. the part where I'm connecting the black one, which is the ground. So the energy wants to go through this path because the resistance through this path is lower than the resistance through the other path. The resistance through the other path being more like 10 kilo ohms. There you go. So now energy wants to go through this path. So the voltage is being divided between the paths, and it's mostly going through this path because the resistance is lower this path. Now, as I press the pedal, the resistance on this path is going to go up, and that means that less energy will want to go through this path because the resistance is too much. In fact, in this setting, the resistance is 11.76. It's greater than the other path. So now the energy is just going through this other path, the tip path. In essence, you can think of energy as going through the circuit. There is a division. It's either going to go through the ring or the tip. And if I have the pedal all the way up, it is going to go through here, through the ring, because the resistance here is lower. And as I push it down, the resistance increases, so energy wants to go through the other path, and voltage is divided. Now, the Arduino does not measure resistance. It doesn't even care about the resistance. But it does measure voltage. There is a pin in the Arduino that is capable of measuring the voltage coming in. So you can have any voltage between 0 and 5 volts, and the Arduino is going to give me that information in the code. Great. So let's plug this little guy in. Oh, before we even plug it in, there are more interesting things we can talk about when I was like understanding and debugging how this guy works. And Bo says, get banana wires with clips. Will free up your hands to test stuff. You're going to need it. Good suggestion. Yes, that's a good point. Right, so continuing with understanding this guy. There is, first of all, this M audio or other situation going on here. So let's see what this does. Let's switch to M audio. Put it all the way up. And then this is the ground. As soon as the stream picks up, I'm learning that Video Ninja locally does not work all that well. I thought it would because it's a local area network, but it seems like it doesn't. So go figure. Next time I'll use something else. Right, so remember, before the resistance on the tip was the same every time, and on the ring, it was changing as we moved the pedal. Now, if I connect these guys, the tip is at 1, and when I push the pedal down, the resistance increases, while the ring has a resistance of about 10 kilo ohms. And no matter what I do with the pedal, the resistance stays the same. So, in effect, the M audio way of doing things is the voltage that changes is in the tip, while in the other setting, the resistance that changes is in the ring. Now, for our purposes, it doesn't really matter which setting we use as long as we are consistent when wiring everything around. And at least to my way of thinking, it makes more sense to have the variable resistance in the middle. I can think of this as like, I am going to charge the tip with 5 volts, I'm going to ground the sleeve, and then in the middle, I will have a wire that is the one that I connect to the analog input in the Arduino to measure the variable voltage caused by the 5 volts being divided between the paths. So that's the story of this little button here. Now, let's look at this one. This one is kind of interesting. I read the manual to understand what this was doing, and for this button, they just said, yeah, you should plug the pedal into some hardware, and if it's M audio, then you should use the M audio setting, but there are some other manufacturers that may also use the M audio setting. and in some cases you do have to switch to other. So it's mostly try it for yourself and see what comes out. If it works, it works. And then for this setting, it's kind of a clever idea. This pedal was meant to be used with like a pedal board, an analog pedal board with real analog hardware pedals. And if you are using this as like a volume pedal, then let's say that when it's like this, it is all the sound is coming through, the volume is all the way up, and then when you do this, the volume is all the way down. Now, this may be too severe for you. Maybe you don't want the volume to go all the way down. You may want to have it quieter and louder, but not all the way quiet. So that's what they say in the manual. You can switch this, you can rotate this to change that. So when it's here in the lower setting, you can see that there is like a little notch here, and that it's pointing at the lowest setting, while this one is the highest setting. It's like thicker. So when it's in the lower setting, it means that it is going to go all the way down. The volume is going to go all the way down. And while it's here, the volume is not going to go all the way down. It's just going to go some of the way down. And then you can adjust this to have the volume as you wish. So let's look at how this knob works in terms of the resistance. So we are in the other setting on the back, not the audio setting. And that means that in the connector, we can use the sleeve and we can use the ring to have the variable resistance. So right now the resistance is ranging from, let me see if I can grab all of these guys since I don't have the right kind of connectors to do this. Let's see if I can grab all of them with just one hand. Yeah, I think I can. It's not perfect, but it's good enough. So right now we are in this lowest setting. The resistance in the middle is 11. And as I rotate this, the resistance is going to go up. But check out what's happening to the outer one, to the tip. The resistance is also going up on that one. So the resistance of the whole thing is going up. One is going to cancel the other. Oh, I'm not showing this part. Yes, as I rotate this, the resistance on the outer one is also changing. So they're going to cancel out. Right, so we already looked at the lowest setting. The tip, let's take note, the tip is at 10 and the ring goes from 11 down to 1. Let's take notes. I know you don't see the notes. I'm going to show all of this on the screen real quick. So in the lowest setting, the tip was at 10 and the ring went from about 1 to about 11. Now, let's switch to the highest setting here, the thicker line. And hopefully the stream will pick this up at some point. That's too bad. Okay, it is back. Right, so let's do the setup again. All right, I'm holding everything. The setting here is the highest setting or the thicker line. And we are on the tip. So that's the one that doesn't change as I move the pedal. And it's at 58. Then if I go to the ring, it goes from 48 to 60, 59. Let me take notes of this as well. Right, so let's review this. When we were in the thin setting, the resistance on the tip was 10, and on the thick setting it was 60, or about 60, and here is a typo. And then the ring went from 1 to 11, and the other one went from 49 to 59. So in essence, the range of this is greater. We are going from almost letting no energy go through. This is even lower than 1. So we are almost letting we are almost getting a path that has no resistance. So almost all the 5 volts are going to go through. While in this setting, 5 volts is never going to go through because the resistance is always bigger than like 10. The resistance here is always high. So this is never going to let 5 volts go through. So the range of voltage that is going to go through, voltage is not a word. I think the word is tension. I don't know. In any case, the range that we get from this setting is less so in terms of volts than the range that we get in terms of volts in the thin setting. And we can play around with this with the Arduino connected and see the numbers we get changing. Okay, my multimeter starts to beep if I don't use it for long enough. Right, so let's connect the pedal to the Arduino and see the Arduino picking up the movements of the pedal. Let's start with the hardware part of this. Let's start by wiring things together. And also let me catch up with the chat. So not the M audio, but the values look to be close enough. I don't know what you mean, Bo. And Jim is here. Hey Jim, great to have you. Hey Leandro, I just wanted to say hi, but something came up. I'm gonna have to catch up when you upload this. Yeah, it's available for watching later as soon as the stream finishes. And the second adjustment pot is lifting the main one from ground. Yes. Right. Okay, so let's start with the circuit for this. And now I'm going to take out this cable. I don't think that the audio stops when I take it out, but who knows? Maybe I will be silent for a moment. Hello? Yes, we still have audio. Great. Of course, when you are building the circuit, you don't want to have energy going through. So that's why it's important to disconnect from the USB cable. So now we can plug this jack in. And the connectors are pretty obvious. They just go from sleeve, ring, and then tip. And we want the connections to go like this. Oh man, the quality on the second camera is so low. Video Ninja is making me unhappy. Let's get some cables. So we know that to begin with, the ground is the ring. So that's this little guy here. Let's connect the ground to the ground in the Arduino. Just like that. And then the tip, because we are using the other setting in the pedal, the tip should be connected to 5 volts. 5 volts is in column 19. Okay, 5 volts is in column 19. Maybe too small to see on the stream, but the labels here are telling me what these things are. So G and D stands for ground, and 5V stands for 5 volts. So essentially, this is just energy. This is just electricity. It doesn't have any sort of meaning for the Arduino. It's just an electricity source for the rest of the circuit. And I think I got it right. Yes, 19. And typically people use black cables for ground and red cables for energy. So That's what I'm doing as well. And then let's connect this to the tip, which is the part that does not vary the resistance. Just like that. And then the ring is the thing that is going to vary the resistance. So it is also going to vary the voltage going through. As I explained, voltage or electricity wants to go through the path of least resistance. Don't we all? So this one, the middle one, it's in line 4. Let me push that in. Yeah, go in there. So it's in line 4. And then this one, I need to connect to the place where the Arduino can measure voltage. It has several ports here that are analog ports, analog input ports. And I think I'm going to just plug this into A0. The analog ports are numbered from A0 to A5. So in our code, we need to be aware that I plugged this into A0, and I'm double checking. Yes, it seems to be correct. So that's the circuit. Now, let's load the code. And there is an example of how to do analog input. That's the example we are going to use. And this circuit is a potentiometer. That's a potentiometer. The pedal is a potentiometer. Oh, let me switch to my screen. Great. So the circuit, there is this example program, and it asks for a potentiometer. We have one. It's the pedal. The center pin, well, when they say the center pin, they mean the one that is going to vary the voltage on. So in our case, it is literally the center pin because we configured the pedal to be that way, but it could be the tip instead. In any case, connect that to analog input 0. Right, that's the analog input that we connected it to. One side, either one to the ground. I connected the sleeve. It doesn't really matter, as the code is saying, but typically the sleeve is the ground on these kinds of jacks. And then the other side to 5 volts. Great. Then the LED, well, we don't have a LED, but we are going to use the built-in LED that is in port 13. So the Arduino board comes with a little LED. We looked at that last time. Then let's look at the code real quick. So they set some variables here that are global variables. They're just essentially settings. They're more like constants. At least these two are. This is going to change. This is the value that is being read from the analog import. Then on the setup, as we talked about last time, you have to set what are the pins that are being used as inputs and what are the pins that are being used as outputs. As far as I understand, these analog input ports can also be used as digital input ports. They can be used as all sorts of things. Oh, and this is not even about the analog input port, it's about the LED. So these little ports can be used, the digital ports can be used as inputs and outputs. So here we are saying that we are using it as output. Then in the loop that is going to run in a loop as the Arduino is running, we are using this function that is called analog read, and we need to say what the pin is that we want to read from. And this value is going to be between 0 and 1023. So we have 10 bits of resolution. It is a value between 0 and 1023. And inside the Arduino, there is a little analog to digital converter that is taking the voltage and transforming that into this number that I just mentioned. And then what this circuit is going to do is blink the LED. We worked with this blink the LED kind of circuit last time. So it works like just set the pin to high, which lights up the LED, then wait for a little while, then set the LED to low, which turns off the light. And these delays are now not hard-coded like they were last week. They are the sensor value. So this sensor value is going to go between 0 and 1023. So if it's closer to 0, the LED is going to wait very little before it turns on and off. It's going to blink faster. And if this value is high, the delay is going to be bigger, so the LED is going to blink more slowly. That's the promise anyway. So I'm going to plug in the Arduino, restart my audio interface, and upload the program, and I see you on the other side. Are we back? Yes, we are. Great. Isn't it fun watching me type in the comments that you are about to see on the chat? Very meta. Right. So the board is plugged in. Our program is ready to go. Let's upload this guy and play around. Okay, done uploading, and the LED is blinking. Let's switch to the bigger second camera view. The LED is blinking. See, it's kind of faint on the camera, but in real life it is a lot brighter. But it's blinking. So now let's move everything to the side. The LED is there, it's blinking. And oh man, as I move it to the side, there is a lot of glare and you can see even less of the LED blinking. Right, so as I move the pedal, the LED is blinking super fast now. Oh, you can barely see this on the screen. But if I cast a shadow, I think that's slightly better. So it's blinking very fast now. And as I move the pedal down, it's blinking more slowly. Cool stuff, huh? Great. But that doesn't excite me too much. I want to see the values. I want to see the numbers. Making the delay be the number is kind of a indirect way of seeing the number. I want to see the number for what it is. So for that, I don't know if there's an example of this or if I got it from the internet. I think I got it from the internet. Serial event, sensor, strings, USB, lots of examples, but none that have like a hello world kind of situation. Oh, there is some examples for MIDI. Great, didn't know that. Let's see, go through this again. Tone, pitch, follower? Sounds fancy. Communication, serial call response, serial event. Yeah, no. Let's go to the internet and look for Arduino serial hello world. Right, great. I think that's all we need actually. So when you're doing the setup, the same way that you set up the pins, if you want to be able to talk to the computer, you have to set up the serial connection. And a serial connection, it is like a MIDI connection or a USB connection in the sense that it's a connection between the Arduino and the computer, but it's using a different technology. It's using the serial port or the serial bus. And then I have to set it up in this manner because when I go to my tools and I enable this serial monitor, well, it's not available because I'm not using the serial begin thing in this script. I haven't uploaded this latest version. But there will be a setting for what is the rate of communication. So how many messages per second, essentially, are we sending between the Arduino and the computer on the serial bus? And both the Arduino and the computer need to agree on that. So over here, I'm saying to the Arduino, when I upload this program, I'm saying to the Arduino, please connect to the computer with this frequency, with this setting, essentially. And on the computer, I will have to have a setting that matches that. And if I want to print anything, this is how I do it. So let's try this out. So the program is still going to do exactly the same, but as it loads, it is going to run this part that is going to print something to the console. And the first time, oh, couldn't find a board connected on a selected port? That's not what I was expecting. Oh, go figure. I have to select this again. No idea why. So maybe now we can... Come on, get out of the way. So maybe now we can open this. Get out of the way. There you go. Serial monitor. There you go. So here is the setting that we need to match on the computer, and that's the setting that we are sending to the board. Right. So let's send this to the board. Then uploading. So there it is. And now let's check our serial port, and nothing seems to be here. That's weird, isn't it? Let's try this again. Let's actually try the thing that we want to do, which is to print the sensor value. Oh, some files are read-only, blah, blah, blah. Upload. Just checking that the sound is still going, because now I'm afraid. Done uploading. Okay. Alt scroll, serial line. Okay, so now it's working. Weird. I don't know why. In any case, we are getting values that are 1023. Can you see that? Yes, you can see that. 1023 as the pedal is all the way down. Let me move this into the view. So as I do this, numbers are going down. And they're also faster because remember that the delays are going. So when I move it down and it's like at 0, there is a delay of 0. So we are getting lots of messages. And the LED is blinking so fast that it doesn't look like it's blinking to me. It just looks lit up. Right, so now we are getting numbers between 0 and 1023. Great. But remember how I said that this setting here would change the resistance, so it would narrow the range. It would make 5 volts not a possibility anymore. We are right now in the thin setting on the pedal, but we can go to the thick one. Now we are on the thick setting of the pedal. And it's still, the topmost is still 1023. So if this was a volume pedal, the maximum volume is still the same. The maximum volume in this case is just like all the way up. There is no volume reduction at all. But if I push it down, it only goes down to 840. So we are narrowing the range because we're never letting the 5 volts go through. Or the 0 volts. I may be misspeaking. It's hard to wrap. I'm having a hard time wrapping my head around this whole voltage splitting or voltage dividing kind of thing. I always find it weird. So I may be getting it reverse. It may be like 0 volts is never a possibility. I think that actually probably that's more accurate. 0 volts is never going through. But that's not what we want. In terms of this pedal kind of thing, we want it to be at the thinnest setting because I want the whole range between 0 and 1023. all the 10 bits of resolution. Cool stuff. Aria is still not better. I'm so sorry, Aria. I hope that this entertains you and helps you feel a little less worse, if that's possible. Right, so this program served its purpose. We understand how to use analog read. We understand how to set all these buttons up. We are ready to start sending expression CC messages in MIDI, the continuous controller messages in MIDI. We have almost everything we need. And that is actually going to conclude the project once we are able to do that, because we are already able to send note on and off when the button is pressed, and I still don't know exactly which messages I want to configure, but now I can. And there are other pedal boards that allow you to configure what MIDI messages are sent, and you have sometimes even proprietary software that you have to install for that. In my case, I can just configure what messages I want to send in the buttons. That's pretty straightforward. So if we do debouncing, which is important, if we do debouncing and we do the analog messages, the CC messages, the project is pretty much over. There is still some work for me to do as homework, which is the enclosure and putting everything, like I'm not going to use these jumper cables, I'm going to use shorter cables, but that's not interesting enough for a stream, I don't think. Right, so let's grab another sketch. And on this one, I want to send MIDI messages. So I think I'm going to start with our little test. Can I open recent test MIDI? And I think I'm going to say that this is going to be the real thing. So I'm going to go to my downloads folder and Arduino, and I'm going to create a folder called pedal board or something. So let's see what we do in the test MIDI thing. First, we have to include this library. Then for the setup, this was for buttons, but I'm going to put this here and comment it out. Then we have this whole previous state kind of thing that, you know what, I may not bring all these things from there, but I do want to bring this part of the code. And that may be all we need. I'll also copy this just for good measure. Oh, actually, we don't want to send note on and note off messages. So not even that is essential. So maybe all we need is this line. Oh, I closed that. Let's go over that again. Open recent, test MIDI. Anything else we have to do in the setup? No. Anything else we have to do in the loop? No. So let's copy. We do need to copy some stuff from here because we want to do the analog read. So let's see. We have the sensor, then the pin mode is for the LED. We'll not have a LED on this version. So yeah, there's nothing else. And then I think that the setup is just going to be nothing. Then on the loop, I want to have something like this. Let's start with reading the sensor value. So I'll do int sensor value is equal to analog read of pin A0. I'm hard coding this pin name here. I can extract variables for this later. So this sensor value, as we just learned from this experiment, is a value between 0 and 1023. But I want values between 0 and 127 because those are the possible numbers I can send as CC messages in MIDI. So I am going to Maybe I can create a packet already. No, not quite. I still want to do this mapping first. So I don't know exactly what to call this. I'm going to call this like MIDI value, for the lack of a better name. So what I want is to use another one of the Arduino library functions. You can look up the documentation in docs.arduino.cc. But I do know about this value, this function. This function takes an argument that is in some range, like from 0 to 1023, and then another range, like from 0 and 127. And this is going to just map this value from this range into that one. But now that I say this out loud, I forget if this is if I should reverse the ranges, if this should be the second one. So let's look up the documentation real quick. Where is it again? I forget. I want to look up Arduino map. There you go. And yeah, from low, from high, to low, to high. So that's it. So now I have a value between 0 and 127. And then I want to check if my value changed. Because if the pedal is just sitting there, the value of MIDI value is not going to change. It's going to remain the same. So I want to check for that. So for that, I need a kind of a global variable to keep track of the previous situation, similar to what we did in our previous scripts last week and similar to what this sensor value global variable is doing over here. I want to remember previous MIDI value. Or maybe even -1, right? Because with a -1 here, the first time we go around the loop, the MIDI value is going to be different from the previous MIDI value. And that means that it's going to send one message with the current expression pedal position when I turn the thing on. And at least on my MIDI keyboard, when I plug it in, and if I have this MIDI logging enabled, I see that it does send MIDI CC messages for the current situation. So I think that's a good thing. So that's what I'm going to do. With a -1 here, it's outside the range of 0 to 127, which means we will always get the MIDI value being different from the previous MIDI value. And then I do have to remember to update this as the last thing. So I'm going to put this here as the last thing. And then I have to check if the MIDI value is not the same as the previous MIDI value. That means there is a new message that we must send. Now let's dive into this function, and then I can even get rid of those implementations because I'm not using node on and node off in this case. And in this case, the node on package is going to be called CC. Now I need to look up MIDI CC message bytes, explanation of MIDI messages, MIDI message format. I think that I will find something in there. Can I have like an example of a MIDI message? Would that be too much? I mean, I can of course figure it out from this explanation, but I would like an example. Oh, come on, guys. Would it hurt to give me an example? Note messages. Selecting instruments. Oh, come on. you're watching this and you know an example of a CC message, the exact bytes I have to send, that would be lovely, because I don't want to have to figure this out myself. Yeah, this is just explaining what messages are. It's not giving me the bytes. Yeah, I think I'll have to figure it out myself, right? I was doing JS effects, so wasn't following. What is it that you didn't get, Leandro? I don't know. Some time has passed. I don't know. I forget. Hmm. Yeah. Saw a guy on Instagram that built a whole MIDI controller from Arduino stuff. 37 euros it cost him. So yeah, we can do a quick tally. The Arduino itself costs like 17. This MIDI foot controller, or just foot expression pedal, costs like 17. So that's about 30. And all the cables and whatnot, you can get it for 37 euros. But let's be honest, if you want to do the enclosure, and in my case, I wanted to have the breadboard and I didn't have a multimeter, I ended up spending more than 100 euros so far, and I don't even have an enclosure yet. So, of course, these things are going to stay. The multimeter is going to stay. I do have the buttons and some more wire than I ever need. And I did buy some other breadboards just in case I do some other project in the future. But let's be honest, if I wanted just something that would work for me, if it wasn't for the fun of building it myself, there is the iRig Blue board that is like, what, 90 euros, and it has 4 buttons. It has Bluetooth, which is, it's nice. It's not something that I will have. Not that I care about it too much. It will be sitting on my desk, but you can get it for 90 euros. It has 4 buttons, and it has 2 slots for expression pedals. Now, of course, you would still have to buy the expression pedals, but for 100-something euros, you would get something that amounts to what I'm building. But I will have more flexibility. I can attach more than 2 expression pedals. I can attach 5 if I had 5 feet. I can do more buttons. I can do sliders, like if I wanted to have sliders on my desk. So, and the fun of building it myself. So not too bad. How the pedal readings added up. Oh, so I'm not sure. I'm not sure if I didn't get something. Maybe what I didn't get is the resistance. I think that the resistance in this setting that is thick, the resistance in the thick setting is not letting 0 volts go through. I think that's the case. And I see now that my camera just stopped sending video. Isn't that great? Let me restart the camera. And not the front camera, the back camera. Start. And mute. Great, it should be back. Right, I think we'll have to figure this out ourselves. This was the only part that I didn't research beforehand. So a MIDI message has 3 bytes. It may actually be a good thing that I didn't do this beforehand, because then I will explain this message in more detail. We may even find the bug, the warning that we were getting from values being out of range. Just making sure that I'm on the right screen. Potentiometer sometimes don't go fully 0, might be it. Yeah, and I don't know exactly how the analog to digital conversion in the Arduino even works. I'm not sure that 0 volts maps to 0. Maybe 0.5 volts maps to 0. Who knows? I'm just so happy that I plugged everything and it worked first try. I didn't have to, like, in the code, try to do something weird. If you just set up the pedal the right way, the Arduino just works with that. Great. So each MIDI message is 3 bytes long. one status followed by two data. The first bit of each oh, and I do think we see that, right? 1, 2, oh no, 3 and 4. So, oh, you know what? Maybe in the USB, MIDI, Arduino, they have some example of this. No. Ah, great. Just sending me back to the top of the language reference. But they don't explain here very well what this message should be. But you know what? We can always go to GitHub. Source. Probably here on the header, we are going to find one of these guys. No? Let's search through the repository. This is an example. And this is sending nodes, sending nodes, sending nodes, sending nodes. This is the implementation. Very lightweight docs. Here we are. We have a header and then we have 3 bytes. And they are integers and unsigned. When we read this stuff, I think I want to have it like that as well. What is the range of values I can store in one of these? From 0 to 255. So no, I don't want to do it like that. Not for all of them. But for the MIDI value, yes. Yeah, I do want to have that for the MIDI value. And that's, I think, the warning that we were getting, because we had an integer and then we were using it in the context where it was expecting one of these unsigned integers with 8 bits. And the result of that is that it would have to narrow this int, which is like what? 16 bits, 32, 64, I don't even know. But it would have to narrow the integer into an 8-bit integer, which is a smaller data structure, and it could be losing information along the way. Hence the warning. It wasn't because of the values we had. That's right. So this guy is an unsigned integer of 8 bits. It only goes up to 7 bits anyway. And then the header, and then for, and what is this header? And then for bits, for bytes. There are all these status things, and then node on. Oh, look at that. We have here the node on implementation, don't we? No, I removed it. Example, open recent, test MIDI. Node on is sending 9, and node off is sending 8. Great. There's something weird. There is like 8 underscore. So I think that these guys are the first bytes on this explanation. What I want is not any of these. I want a control mode change, I think. Oh, status, blah, 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 the control change message. Then we have a status byte, data byte 1 and data byte 2. Okay, so it starts with a B. So I think we want to change this into a B. And then we need to say not the channel, Oh, I do think we need to say the channel here. But then we also need to say which kind of message we want to send. Yeah. Oh, we do have a foot pedal kind of thing. That's cool. But I do want this to be like expression. So I want it to be like 11. And this is data byte 1 from 0 to 127. So I want it to be 11. And then the velocity here is not velocity. That is our MIDI value. And what if I just change this to a B? Random guessing, but it may work. And in terms of the channel, I think I'm just going to send this on channel 1. Or actually, I think channel 1 is actually channel number 0. What we typically call channel 1 is numbered from 0 up to 15. So I think that this is going to work. And then we send the MIDI message and then we flush. I don't know. Yeah, let's figure it out. Let's send this. Uploading to the board. You probably need a conversion that translates the values from the pedal to manageable values for the Arduino. 0 logarithm taper to linear, etc. I don't think I need to do these conversions. I think that the analog to digital converter in the Arduino is doing most of this for me. I think that the values we are going to get are just going to work. Yeah, I don't know. We'll figure it out. So right now, I uploaded everything and you can see, yes, you can see this. Go to Reaper and we are receiving messages. Look at that. It worked. We did it. And if I leave the pedal like here, it's fine. Before I was kind of seeing some fluctuation. Maybe I was with the pedal exactly in a position. I don't think you can see this, can you? It's right behind me. It was probably in a position that was in between two states, so it was sending a bunch of messages, but that's all right. I don't really care. It's working. It goes between 0 all the way to 127. Oh, I guess this is the state that is fluctuating. But then it stabilizes. So that's fine. There you go. It worked. I'm so happy. And it is in channel 1, so my numbering was correct, and it's sending the kind of expression message that I think it should send. Yay! Quick, and then we'll call it a day. So I am now going to plug in a button as well as the expression pedal. So we are going to take this program as a reference, and we are going to, I think at this point, probably the analog input served its purpose. So I'm going to close that one. I don't need to save it. And then we do need to read from a button. So I will need to do this. And maybe I'm going to start having those constants. To name this one button. It is connected to port 7. It's going to be connected to port 7. Expression. Expect to buy more in the future. It's connected to analog port A0. Where I read from there, I can do it like this. Then previous state and this previous MIDI value, they also have names. Let's start with the previous MIDI value. It is previous expression pedal value. And sensor value needs to change into, well, actually, this sensor value is only used here. So I'll wrap this in a single line. And then I'm doing an analog read and mapping the value. I think that makes sense, right? But I'm also mapping in a single line because I am reading and I want the number to be in this center, this particular range. So I do this in a single line. Then this MIDI value needs to be pedal 1. Oh, previous expression, pedal 1. And yes, I'm code. I could have arrays and loops, good stuff like we are doing in JS Effects, but I am not going to. I'm just going to start with copying and pasting, and then if I really think I need, I will do loops. But this is going to be such a I don't think. So expression pedal 1, if it's different from the previous expression pedal 1 value, then do all these shenanigans. Right? So let's continue. This is going to change into that. And then instead of having a previous stage, I'll have a previous button stage is equal to 1 in this case, because when the button is not pressed, it's 1, and then when it is pressed, it's 0. Previous button 1 stage. Then in the loop, I'm going to have something that amounts to this. And then current stage is button 1 stage. And then current stage and that, and button has been pressed. I'm not going to extract that into a variable. I'll just have it right there. And the previous stage is now this. And then this note on, just going to paste it here and change all the variables accordingly. So channel 0, pitch 60, and velocity 127. Or maybe I will extract this into a function. Nope, I'm going to do it like this. So now I don't call note on. And note off goes like this. Channel 0, pitch 60, velocity 0. And I don't need to call note off. It's in the name, right? Note on, note off. Great stuff. Let's see if I am missing something. Yeah, probably I want to move this down. And previous stage and current state have been renamed. Now it's button 1 stage. This is that. You know what? I'm going to put it back. So it goes like, this is the part that is taking care of the button, and this is the part that is taking care of the expression pedal. All very neatly separated. It's not conventional to have variable declarations here in the middle, and maybe Arduino is going to complain about this. But we'll see. I think that everything else stands. Right, so we are done with this. Oh, let me see. Do you have a hard code? Do you have to hard code a channel? We could have different channels. Your audio cuts out randomly, by the way. Sounds like a limiter on the zoom. No, it's probably the Arduino fighting the zoom. Yeah, I don't know about that. This is probably going to be the last stream with the Arduino, and I will never figure out why plugging in the Arduino makes the audio interface go down? I don't know. I hope you can hear me now. Yes, you can hear me now. Right, so let's switch to this and review what we have. So we have our button states. Yeah, button setup, button states. This, and then digital read. That. And this is essentially the part that would turn into a loop if necessary. So let's see. All of that makes sense. I'm going to make something that makes me happy. I prefer to read it like this. All right, let's. I need to rebuild the system here with the button. I took it off, but I don't want to reconnect the Arduino because of the sound issues. So I'm going to do something that you shouldn't, which is to wire things with the live system. Hopefully I won't blow anything up. And then I'm going to upload the program. Oh, MIDI value should be expression pedal 1. Just making sure that the audio is still coming through. It is. Great. Uploading. Done uploading, actually. It's done. So just checking the audio again. Great. So we can use the expression pedal and we can use the little button. Let me try to get a debouncing kind of situation going wrong here. Yeah, I'm not getting too much here. So maybe this is just a guess. Let's talk about what the issue and what I would do to solve it. So the issue is that we do a read, and then we go around the loop and we send notes if necessary, and then we remember the previous state, and then we go around and do a read again, and all of that is good stuff. But if we go fast enough, we can do digital reads of the noise in the middle when the button is like kind of pressed and kind of not pressed. And my quick and dirty solution for this was going to go like this. I was going to, oh, and this guy is just on and off, so I think it could be like a Boolean. Yeah, bool is a value. You know what? I just want to test if this works. I think it does. Bool. And do I have something like true? Yeah, great. And then, no, I'm not going to change this now. Yeah, so my quick and dirty solution for debouncing was going to be something like this. I read once, and then I delay for a small amount of time, and then I read again. And then if the two states agree, then I do all that. Well, actually including this. In other words, I only act if the values agree 20 milliseconds apart. That's a kind of a hacky solution. It's quick and dirty because it is introducing a delay that is going to delay even this, which is kind of silly. But it's a solution. It does debounce. But maybe, just maybe, this analog read and all this situation going on here already slows down the system so much that there is sort of a delay between the two already. I don't know. Let's check this out. I couldn't really make anything bounce in the other program. Oh, it's done uploading already. But let's try to see if we get even better results now. Yeah, I don't think there was a single time I pressed the button and I got more events. So that wraps up the debouncing quick and dirty solution. And even for the expression pedal, there is a delay of 20 milliseconds every time. But really, who can tell? It's working fine. So there you have it. This takes care of the bouncing, and we worked on all the to-dos. So the only thing left to do is the enclosure and then attaching more buttons and copying and pasting some code. Maybe I'll do a loop, maybe I'll do a raise, but probably not. Just copy and paste seems fine. And then in here, I can decide which message I want to send. Like this is sending a note on node 60, and this is sending a value of 11, which this is actually 11, so the list of messages starts with a 0. Kind of cool stuff. Right, so that wraps it up. That's how you do an Arduino pedal board or any other kind of MIDI controller. You could have buttons that you touch with your fingers. You could have sliders. They are just potentiometers, just like this pedal here. So yeah, that's how you do all this good stuff. Thank you everyone for watching this. I will not be streaming tomorrow, but I see you again on Thursday, and we'll continue our JS Effects library. We will talk about pink noise. Yeah, hope you all have a great Wednesday, and I see you back on Thursday. Bye.